Just-in-time manufacturing, also known as just-in-time production or the Toyota production system, is a methodology aimed primarily at reducing flow times within production as well as response times from suppliers and to customers. Following its origin and development in Japan, largely in the 1960s and 1970s and particularly at Toyota, JIT migrated to Western industry in the 1980s, where its features were put into effect in many manufacturing companies, as is attested to in several books and compendia of case studies and articles. From the 1980s, alternative terms for JIT manufacturing have been used. Motorola's choice was short-cycle manufacturing, IBM's was continuous flow manufacturing, and demand flow manufacturing, a term handed down from consultant John Constanza at his Institute of Technology in Colorado. Still another alternative was mentioned by Goddard, who said that Toyota production system is often mistakenly referred to as the Kanban system, and pointed out that Kanban is but one element of TPS, as well as JIT production. But the wide use of the term JIT manufacturing throughout the 1980s faded fast in the 1990s. As the new term lean manufacturing became established as a more recent name for JIT, as just one testament to the commonality of the two terms. Toyota production system has been and is widely used as a synonym for both JIT and lean manufacturing concept. The nature of just-in-time, meaning JIT manufacturing, production or JIT in any other setting, may be reduced to four somewhat differently stated views. Many have said that JIT revolves around wastes. At its core, JIT is a waste elimination philosophy. Among the earliest writings on the matter, Shingo lists as the 7 wastes the wastes of overproduction, waiting, transportation, processing itself, stocks, inventories, motion, and making defective products. Others have equated JIT production with Kanban. For example, one book has both Kanban and just-in-time in its main title. Still others assert that JIT's main aim is elimination of inventories. Although Murray maintains that JIT is defined as not an inventory control system, but a way of thinking, working and management to eliminate wastes in the manufacturing process. In keeping with that view, JIT manufacturing has often been referred to in contrast to the more conventional just-in-case mode. JIT keeps extra inventories to be used in case of disruptions, whereas JIT continually reduces such inventory buffers by continually attacking causes of disruptions. Zero Inventories is the title of a 1983 book by Hall, but the book actually does not suggest that JIT is mainly about inventory. Rather, the book features quick setup, cells, Kanban, and so on. And zero inventory is posed only as an unattainable ideal, one that is easy to see and count. The fourth view is that JIT is mainly about quick response, relating to the T4 time in JIT. As Blackburn put it, quick response is one of the major benefits of JIT. Time or speed is the linchpin of this manufacturing philosophy. Inventory, on the other hand, is an ancillary benefit. Quick response refers alternatively to reduction of cycle times, flow times, throughput times, and, all the way to the customer, lead times. JIT, according to Bacino, has the provocative goal of producing instantaneously, with perfect quality and minimum waste, and he goes on to qualify instantaneously by saying, the ideal way to produce the end product is literally just in time to meet the market demand for it. Thus, JIT is primarily a lead time reduction program. The four JIT views, referring to wastes, Kanban, inventory, and quick response, lead time reduction, do not suggest opposing views, but rather appear to be complementary points of emphasis, collectively serving to describe the essence of JIT. Aside from the four viewpoints, just-in-time has often been paired with total quality control, forming the acronym JIT, TQC. The rationale is that TQC avoids stoppages and slowdowns disruptive to the quick flow aims of JIT, and JIT exposes quality issues and their causes soon after they occur, thus facilitating their elimination. Methodology. Safari provides a list of methodologies of JIT manufacturing that are important but not exhaustive. Housekeeping, physical organization and discipline. Make it right the first time. Elimination of defects. Set up production. Flexible changeover approaches. Lot sizes of 1, the ultimate lot size, and flexibility. Uniform plant load, leveling as a control mechanism. Balanced flow, organizing flow scheduling throughput. Skill diversification, multifunctional workers. Control by visibility, communication media for activity. Preventive maintenance, flawless running, no defects. Fitness for use, producibility, design for process. Compact plant layout, products-oriented design, streamlining movements, smoothing materials handling, supplier networks, extensions of the factory, worker involvement, small group improvement activities, cellular manufacturing, production methods for flow, pull system, signal, Kanban, replenishment, resupply systems. Voss and Clutterbuck offer, in a different style, their own list of some of JIT's methodologies. That list, following, includes citations from other sources. Flow, layout, smooth line build rate, mixed modeling, to allow the concurrent assembly of different models on the same line. Setup time reduction, work in process reduction. Kanban, a pull system that triggers the movement of materials from one operations through to the next. Quality, a prerequisite of successful JIT. Product simplification, e.g., using fewer and common parts. Standardized containers. Preventive maintenance, removal of the uncertainty of breakdowns, often referred to as total productive maintenance. Flexible workforce, via cross-training, organization in modules or cells, continuous improvement, JIT purchasing. Two notable elements are JIT purchasing that could be separately listed as single sourcing and milk runs. Single sourcing means using just one supplier of a given item or items, thus to reduce complexities and difficulties in developing JIT relationships with the supplier base. Hall states that if the single source fails to perform, an alternative source is available. In contrasting terminology, a sole source means there is no other source with suitable capability, possible for technological or quality reasons. Hall goes on to say that in case of a fire at the supplier plant or other emergency, some reserve capacity in supplier operations dedicated to other networks can be called to cover it. One localized calamity does not destroy everything, and if the supplier has good people involvement, strikes are a minimal risk. One item missing from the Voss and Clutterbuck list is visual management. Everything orderly, simple, and easily seen and found formalized as the 5 S's. History. Exactly how JIT emerged as an approach to manufacturing management is obscured in an inevitable cloud of mythology, though it is clear that its development was primarily in Japan. The author of that statement goes on to say that the first to use JIT was not Toyota but was Japan's shipyards, which wanted to establish firmer control over the delivery of steel plate and fittings. A point echoed by Goddard. Evolution in Japan. Why in Japan rather than other countries? Plinet offers 4 reasons, paraphrased here. During Japan's post-World War II rebuilding of industry. 1. Japan's lack of cash made it difficult for industry to finance the big batch, large inventory production methods common elsewhere. 2. Japan lacked space to build big factories loaded with inventory. 3. The Japanese islands were lacking in natural resources with which to build products. 4. Japan had high unemployment, which meant that labor efficiency methods were not an obvious pathway to industrial success. Thus the Japanese leaned out their processes. They built smaller factories, in which the only materials housed in the factory were those on which work was currently being done. In this way, inventory levels were kept low, investment in in-process inventories was at a minimum, and the investment in purchased natural resources was quickly turned around so that additional materials were purchased. Pleenart goes on to explain Toyota's key role in developing this lean or JIT production methodology. Migration to the West. News about JIT TPS reached Western shores in 1977 in two English-language articles. One referred to the methodology as the Ono system, after Taiichi Ono, who was instrumental in its development within Toyota. The other article, by Toyota authors in an international journal, provided additional details. Finally, those and other publicity were translated into implementations, beginning in 1980 and then quickly multiplying throughout industry in the United States and other developed countries. A seminal 1980 event was a conference in Detroit at Ford World headquarters co-sponsored by the Repetitive Manufacturing Group, which had been founded in 1979 within the American Production and Inventory Control Society to seek advances in manufacturing. The principal speaker, Fujio Cho, in explaining the Toyota system, stirred up the audience and led to the RMGs shifting gears from things like automation to JIT, TPS. At least some of audience's stirring had to do with the perceived clash between the new JIT regime and MRP2, a computer software-based system of manufacturing planning and control that had become prominent in industry in the 1960s and 1970s. Debates in professional meetings on JIT versus MRP2 were followed by published articles, one of them titled, "The Rise and Fall of Just-in-Time." Less confrontational was Walt Goddard's Kanban versus MRP2, which is best for you, in 1982. 4 years later Goddard had answered his own question with a book advocating JIT. Among the best-known of MRPII's advocates was George Plossel, who authored 2 articles questioning JIT's Kanban planning method and the Japanning of America, but, as with Goddard, Plossel later wrote that JIT is a concept whose time has come. JIT TPS implementations may be found in many case study articles from the 1980s and beyond. One article in a 1984 issue of Inc. magazine relates how Omark Industries emerged as an extensive JIT implementer under its homegrown name Zips at Omark's mother plant in Portland, Oregon. After the workforce had received 40 hours of Zips training, they were turned loose, and things began to happen. A first step was to arbitrarily eliminate a week's lead time, after which things ran smoother. People asked that we try taking another week's worth out. After that, Zips spread throughout the plant's operations like an amoeba. The article also notes that Omark's 20 other plants were similarly engaged in Zips, beginning with pilot projects. For example, at one of Omark's smaller plants making drill bits in Mesabi, Min, large-size drill inventory was cut by 92%. Productivity increased by 30%, scrap and rework dropped 20%, and lead time from order to finished product was slashed from 3 weeks to 3 days. The Inc. article states that companies using JIT the most extensively include the Big Four: Hewlett-Packard, Motorola, Westinghouse Electric, General Electric, Dare, and Black & Decker. By 1986, a case study book on JIT in the U.S. was able to devote a full chapter to Zips at Omark, along with 2 chapters on JIT at several Hewlett-Packard plants, and single chapters for Harley-Davidson, John Deere, IBM Raleigh, North Carolina, and California-based Apple Macintosh, a Toyota truck bed plant, and new United Motor Manufacturing joint venture between Toyota and General Motors. 2 similarly inclined books emergent in the UK. In the same years are more international in scope. One of the books, with both conceptual articles and case studies, includes 3 sections on JIT practices. in Japan, in Europe, and in the USA and Australia. The second book, reporting on what was billed as the first international conference on just-in-time manufacturing, includes case studies in 3 companies: Repco Australia, IBM UK, and 3M UK. In addition, a Day 2 keynote discussed JIT as applied across all disciplines, from accounting and systems to design and production, middle era and to the present. 3 more books that include JIT implementations were published in 1993, 1995, and 1996, which are startup years of the lean manufacturing, lean management movement that was launched in 1990 with publication of the book, The Machine That Changed the World. That one, along with other books, articles, and case studies on lean, were supplanting JIT terminology in the 1990s and beyond. The same period, however, saw the rise of books and articles with similar concepts and methodologies but with alternative names, including cycle time management, time-based competition, quick response manufacturing, flow, and pull-based production systems. However, there is more to JIT than its usual manufacturing-centered explication, inasmuch as manufacturing ends with order fulfillment to distributors, retailers, and end users, and also includes remanufacturing, repair, and warranty claims. JIT's concepts and methods have application downstream from manufacturing itself. A 1993 book on world-class distribution logistics discusses Kanban links from factories onward, and a manufacturer-to-retailer model developed in the U.S. in the 1980s, referred to as quick response, has morphed over time to what is called fast fashion. JIT implementation design, based on a diagram modeled after the one used by Hewlett-Packard's Boise plant to accomplish its JIT program. F. Design flow process. F. Redesign, relayout for flow. L. Reduce lot sizes. O. Link operations. W. Balance workstation capacity. M. Preventive maintenance. S. Reduce setup times. Q. Total quality control. C. Worker compliance. I. Automatic inspection. M. Quality measures. M. Fail-safe methods. W. Worker participation. S. Stabilize schedule. S. Level schedule. W. Establish freeze windows. UC. Underutilize capacity. K. Kanban pull system. D. Demand pull. B. Backflush. L. Reduce lot sizes. V. Work with vendors. L. Reduce lead time. D. Frequent deliveries. U. Product usage requirements. Q. Quality expectations. I. Further reduce inventory in other areas. S. Stores. T. Transit. C. Implement carousel to reduce motion waste. C. Implement conveyor belts to reduce motion waste. P. Improve product design. P. Standard production configuration. P. Standardize and reduce the number of parts. P. Process design with products design. Q. Quality expectations. Objectives and benefits. Objectives and benefits of JIT manufacturing may be stated in 2 primary ways. First, in specific and quantitative terms, via published case studies. Second, general listings and discussion. A case study summary from Damon Products in 1999 lists the following benefits: reduced cycle times 97%, setup times 50%, lead times from 4 to 8 weeks to 5 to 10 days, flow distance 90%, achieved via 4 focused factories. Pull scheduling, Kanban, visual management, and employee empowerment. Another study from NCR in 1998, a producer of made-to-order automated teller machines, includes some of the same benefits while also focusing on JIT purchasing. In switching to JIT over a weekend in 1998, eliminated buffer inventories, reducing inventory from 47 days to 5 days. Flow time from 15 days to 2 days, with 60% of purchased parts arriving JIT and 77% going doctor line, and suppliers reduced from 480 to 165. Hewlett-Packard, one of Western industry's earliest JIT implementers, provides a set of 4 case studies from 4 HP divisions during the mid-1980s. The 4 divisions, Greeley, Fort Collins, Computer Systems, and Vancouver, employed some but not all of the same measures. At the time, about half of HP's 52 divisions had adopted JIT. Among general discussions of JIT's objectives and benefits is this from Malakuta: reduced setup time. Cutting setup time allows the company to reduce or eliminate inventory for changeover time. The tool used here is SMED. The flow of goods from warehouse to shelves improves. Small or individual piece lot sizes reduce lot delay inventories, which simplifies inventory flow and its management. Employees with multiple skills are used more efficiently. Having employees trained to work on different parts of the process allows companies to move workers where they are needed. Production scheduling and work hour consistency synchronized with demand. If there is no demand for a product at the time it is not made. This saves the company money, either by not having to pay workers overtime or by having them focus on other work or participate in training. Increased emphasis on supplier relationships. A company without inventory does not want a supply system problem that creates a part shortage. This makes supplier relationships extremely important. Supplies come in at regular intervals throughout the production day. Supply is synchronized with production demand and the optimal amount of inventory is on hand at any time. When parts move directly from the truck to the point of assembly, the need for storage facilities is reduced. Minimizes storage space needed. Smaller chance of inventory breaking, expiring. The author sums up with the comment, waste elimination supports continuous quality and productivity improvement.